we're going to get into solving right triangles, and a lot of this is going to be familiar to you from geometry, and it's things that we've kind of used before, but we're going to be doing it, so I may go over it a little bit quick. If you have questions, make sure you ask in class or come to tutoring and ask those questions. Okay, so in this first example, we're given an angle and a side, and I need to solve the right triangle, which means find the other parts to it. And right now, all of these are going to be right triangles. So first, with that angle and side, I got to figure out what I can use that for. Well, because I'm given an angle and it's a right triangle, that means I have two angles. So what I can do to find theta, let me try and find theta first. And I'm going to take theta plus 56 is going to equal 90 degrees. And if I subtract 56, so that means theta is equal to 34 degrees. Because all three angles add up to 180, this is already my 90 angle, so theta and 56 add up to 90, and there I go. That's theta. My next part, I'm going to look for A. So to find A, I'm going to use cosine. So I have 56. So that means if I take cosine of 56 degrees, that's going to be equal to adjacent over hypotenuse, and my adjacent is A. My hypotenuse is 15. So then to solve for A, I multiply both sides by 15, and I get cosine of 56, or I'm sorry, A. Let me write A on this side. A is equal to 15 times cosine of 56, which then is approximately 8.38789. And I'm going to round to the hundredths place, so I get A is approximately 8.39. And now to find B. Well, to find B, I can use sine of angle 56, and that's going to be the opposite over hypotenuse. So my opposite is B divided by 15 is the hypotenuse, and again multiply both sides by 15, and I get B is 15 times the sine of 56, which B is approximately 12.43556, and round to the hundredths, and I'm going to get 12.44. And these parts you do need the scientific calculator to find the sine of these angles and measures, but you'll be able to use that this time around. Okay, one more example, and in this one we have just two sides, and so I'm going to use those two sides to figure out all the other parts to the triangle. And these other parts, I have side A, angle beta, and angle alpha. And so let me solve for angle alpha first. And I'm going to use the cosine of that angle alpha, is equal to adjacent over hypotenuse, and my adjacent is 19.67 over 37.21. And remember how to find these when I don't know what the angle is, but I know the sides. We use the inverse. So the inverse of the inverse of cosine of 19.67 divided by 37.21 is going to equal my variable of alpha. And so when I do that part in the calculator, remember it's normally the second button that you have to use, that becomes 58.0876485. And so I have approximately 58.09. And now that I have that, I can solve for beta, because now I have two angles, the 90 degree and the 58.09 degree, and so beta plus that alpha 58.09 has got to equal 90 degrees. If I subtract 58.09 from both sides, I have beta is approximately, it's still approximately because I rounded to get that 58.09. That means this is going to be 31.91. And to solve for A, because I have two of the sides and it's a right triangle, I can use Pythagorean theorem. And so that's what I'm going to do. A squared plus B squared is equal to C squared. And I have my hypotenuse, so I have 19.67 squared plus B squared is equal to 37.21 squared. And so this becomes 386.9089 plus B squared is equal to 1,384.541. 5841. And when I subtract 386.9089, I'm running out of room, so I'm going to improvise here. I may erase some stuff. 1 second. I get 997.6752. And I'm going to go over here. I'm going to erase that. So I get B squared is equal to 997.6752. And take the square root of both sides. And I get B is approximately 31.59. And that's it for today. I have one you-try question. Go ahead and try to solve all the rest of the parts for this triangle. And we'll go over it in class along with some more examples. Okay, here's a joke. What did the rope say when it got tangled? Oh no, not again. Oh. You like that one. That was pretty dumb.